ladies and gentlemen. With this first presentation, we want a bit to set the scene also for the following two presentations. And that means, on the one hand, we want to address the questions, what are the main drivers for defossilization of large bore engines? Why are we talking about that? Why is defossilization expected to become this relevant in the future? What are the key challenges related to that? But also to answer the question, what are opportunities to address these questions in the future? To start with that slide here, with the key message, overarching driver for greenhouse reduction targets, which have been defined for different application types, are the overall CO2 reduction targets defined for, at the end, all of the key market areas worldwide. As we see on the left-hand side, for most of the markets, for most of the countries, there have been, according CO2 reduction targets being defined, about 50% in average for 2030, and for most of the markets, at least to become also CO2 neutral by 2050. Some markets with even more aggressive targets, like for example Germany, like for example the UK. Some markets with a bit more relaxed targets, like for example India. But for all markets, we have according targets being put in place. And if we have a look to the European regulation, the European Green Deal, also with various policy areas, these are going to address also the CO2 emissions being related to the transport sector. So the key message here, these challenging worldwide targets, this will demand strong CO2 reduction measures across all industries. So there will be no industry in the future which can also neglect these overarching CO2 reduction targets. And if we talk about CO2 reduction and the contribution to overall worldwide CO2 emissions, the clear message from that slide also should be, yes, the large bore engine sector is also a very important contributor to overall CO2 emissions. So if we have a look to the chart on the left-hand side, for overall CO2 emissions, the shipping, the marine industry, is contributing to about 3% to the overall emissions. And if we just relate it to the transport sector, it's even close to 10%. Also rail with a significant contribution here, and also considering other sectors, like for example, the generator sets, which also would be included here in the electricity and heat generation, and also large construction machines, the mining industry, also with according significant contribution here. On the other hand, what we also see for all of these industries, also according initiatives already have been started, have been put in place. So looking to marine, we have the IMO greenhouse gas reduction targets, minus 50% until 2050. And even the long-term target, to become CO2 or greenhouse gas neutral latest until 2100. There is also so-called Getting to Zero coalition, where also some of the main fleet owners, the marine fleet owners, also already defined targets to become CO2 neutral already at a quite earlier point of time, until 2030 timeframe. Also for the generator set market, we see quite some strong push here. We have the cost pressure. We have the cost pressure from the CO2 permit prices. We have increasing customer demands for green energy. We have, for the rail industry, also a commitment to become carbon neutral until 2050. And also more and more mine operators, mining companies, they also already set targets to reach at least net zero emissions, mostly also before 2050 timeframe. Let's have a bit closer look to the marine industry in the following slides. So focusing on marine, on the one hand, we have the IMO emission limits, which should not be the key focus of the presentation today. On the other hand, we also have several measures which already address reduction in CO2 emissions, respectively greenhouse gas emissions. So on the one hand, we have the EEDI, the Energy Efficiency Design Index, which is defining targets for CO2 being emitted per unit of transport work. And this is, for example, also including the fuel consumption of main and auxiliary engines, so directly addressing also the high-speed engines here. In addition to that, we have the so-called Ship Energy Efficiency Management Plan, which is a mechanism also to improve the energy efficiency during ship operation, manage the ship and the fleet efficiency here. And last but not least, as already mentioned before, we also have the IMO greenhouse gas targets, which set a roadmap for greenhouse gas emission reduction mid and long term, also for the marine industry. In addition to that, there also might be some local requirements, some market areas, some cities, which most probably in the future will also define individual targets. How does that look like from the timeline perspective? To focus on the first hand here on the EEDI and SEMP regulation. So the first steps of the regulation already being in place. Next step regulation also partly being defined, respectively, at least some targets, also for the long-term perspective already being defined. In addition to that, we have the greenhouse gas reduction target, the minus 50% reduction in global greenhouse gas emissions from shipping until 2050, and latest 2100 to become zero greenhouse gas. And very important to have in mind, this is not just related to new shipbuildings. This is the overall greenhouse gas emissions from the marine fleet. And in addition to that, as also already mentioned, there is also several voluntary CO2 emission targets, like, for example, this Getting to Zero coalition, where also according targets to become even CO2 neutral, at an earlier point of time have been defined. What is the big challenge now? And this is what we wanted to address with that slide. So on the one hand, on the left-hand side, we see a projection of the global shipping demand, in billion ton kilometers from 2015, 2050. So this slide, I think, clearly shows, that we also have to expect a strong increase, with regard to shipping demand in the future. And this is also directly related to an according increase in CO2 emissions if we would not react with any measures on this increase in CO2 emissions. On the other hand, and this is what we wanted to point out on the right-hand side of that slide, even if we take into account the EEDI measures, the SEMP measures, as introduced on the previous slides, there most probably will still remain a significant gap, even if we just have a look to the 50% reduction target until 2050 timeframe. There will be a huge gap, with regard to CO2 reduction, which has to be filled, also with according additional measures. So that means new technologies, especially also including alternative fuels, need to be introduced into the market in order to comply with these CO2 reduction targets. On the other hand, also saying it's not just the regulation which is putting a lot of pressure in reducing CO2 greenhouse gas emissions in the future. It's also, as already mentioned, the large fleet operators. Some of them also want to become forerunners, in with regards to sustainability trends. There is also the increasing demand with regard to life cycle assessment. More and more companies looking to a sustainable value chain, the green image. We also have the green image being demanded by commercial yacht owners, for example, sustainable luxury yachts for the green image. And there is also, to a certain degree, also the public pressure, also to include other industries, not just the on-road transportation, with regard to future CO2 reduction needs. So what are the options in order to address the future CO2 reduction needs. At the end, we have several options to do that. We still have the engine optimization. We have electrification measures, hybridization, battery electric. We have the fuel cell technology, and we also have various alternative fuel options here. And as we pointed out on that slide, with regard to, on the one hand, the zero CO2 potential, on the other hand, the zero pollutant potential, there are quite some differences if we assess the different options here. Some of them might be zero CO2, but as we are still burning a fuel in an internal combustion engine, they are not really zero pollutant free. And of course, for these fuel options, which are also highlighted or mentioned here, we also need to ensure that the fuels are also produced from renewable sources in order to be finally really zero CO2 fuel options here. So in order to achieve the zero CO2 or the significant reduction in CO2 emissions in the future, most probably engine optimization, hybridization, and also the use of fossil LNG or LPG will not be sufficient in order to reach the future greenhouse gas targets. So this clearly means we will require new energy carriers, and there will be additional challenges being related to that. What about the infrastructure? What about the availability of the fuel? What about the distribution network? What about also the bunkering capabilities in the marine sector, for example? What about energy storage? How easy can a certain fuel option, energy carrier option being stored? What about a joint fuel strategy? As also according investment needs to be done for the different fuel options. And finally, also which costs are related to the different options here. What we expect, that there will be different technology strategies, and we will also come back a bit more in detail to that in the following slides, depending on application type, probably also depending on specific market areas. One always needs to find the right trade-off between the application fit, also infrastructure availability, and the related cost implications. Talking about energy storage, I think also one very important aspect is the energy density. So what you see on that slide here, is the energy density for different fuel options. On the one hand, on a gravimetric basis, on the other hand, on the volumetric basis. The key message here, if we consider the different fuel or energy carrier options, we see quite some significant differences here. Even for the liquid fuels, if we compare an LNG, if we compare a methanol or also an ammonia against conventional diesel fuel, we will have some drawbacks with regard to energy density, both on a volumetric, also on a gravimetric basis. If we consider the gaseous fuel options, in particular with regard to volumetric energy density, there are some quite significant drawbacks. And if we take battery electric into account, it's even more than an order of magnitude, what we see here as a drawback with regard to energy density for both volumetric and gravimetric basis. And taking that into account, I think one clear message will be, maybe a bit in contrast also to the on-road sector, that full electric propulsion just has a limited capability for the typical large bore applications. As if we talk about battery electric, we will need significant volume for the energy storage. The batteries also will be related to very high costs, and at the end, electric propulsion probably will only be suited for some selected use cases. Yes, for a ferry with a plannable route, for maybe a super yacht application, or also for a hybrid tugboat, this is really an interesting solution. But for other applications, probably electricity alone cannot be the only replacement for high-speed engines. So we need alternative fuel options like hydrogen, like methanol, like ammonia, like also other fuels being derived from renewable energy sources. And as we now quite focused a lot on the marine sector, also with that slide clearly addressing or stating it's not just only the marine sector, also for the other industries, which are relevant for high-speed large bore engines, whether we talk about generator sets, whether we talk about rail, but also the mining sector or the larger construction machines. Also here, we have according defossilization needs, for these applications. For the generator sets, as mentioned also before, customers also asking for green solutions here, and we will still need internal combustion engines for the data centers, for peak shielding, also in combination with regenerative power in the future. In the rail sector, there will always be some market with low or limited electrification shares. We sometimes have the challenge of the last mile delivery, for example, in harbor areas where we also still might need internal combustion engines in such applications. And then, of course, the question will come up, what is the most feasible, the best fitting solution with regard to alternative energy carriers? And the clear message here from that slide, there will not be the one and only solution. It will not be a black and white. So if we have a look to the left-hand side of that slide, where we assessed 3 examples of alternative energy carriers with regard to different criteria, I think we can easily see there are pros and cons for each of these energy carriers. Whereas a hydrogen has clear benefits, if it comes to greenhouse gas emissions, if it comes to local pollutant emissions, the hydrogen has significant drawbacks with regard to infrastructure and onboard storage. And this is where the liquid fuels, like a methanol, for example, then also show their benefits. On the other hand, with regard to overall greenhouse gas emissions, with regard to local pollutant emissions, there are some drawbacks compared to the hydrogen as an alternative fuel. And now looking to the right-hand side of that slide, looking to the different application types where we assessed the relevance of these criteria for the different application types, I think we can also easily see the relevance is also different here for the different application types. And this clearly leads to the conclusion that there will not be the one fits all solution, but one need to find the right solution for any specific use case. So it's here at the end, it's a kind of a trilemma, how we illustrated that here on this slide. On the one hand, you need to take the costs of the technology solution into account, the environmental friendliness, greenhouse gas emissions, but also other pollutant emissions being very important. And last but not least, also the infrastructure needs to be available, needs to be mature in order to make that energy carrier solution fit. And this question, I think, is also what we are going to address now a bit more in detail in the following presentation. And this leads me to the end of my presentation. Thank a lot for your attention and also happy to answer any questions.